So this is lesson 102 in Algebra 1, and this section is called Absolute Value Inequalities. Okay, so first of all, let's talk briefly about absolute values. Alright, an absolute value, or a number, let's just look at a number right now, has really two parts. The number 13 has the bigness or the quantity of the number, but it also has the sign of the number, whether it's a plus sign or a negative sign, a positive or a negative sign. So those are the two parts of a number. And when you look at the number line, like I have right there, positive 13 is going to show up right there, and negative 13 is going to show up right there. Just depends on whether there is a positive in front of the 13 or a negative in front of the 13. Now, one of the things that you need to notice, and I know this seems real elementary, is that both numbers are 13. Okay? So what does that 13 mean? That 13 means how far are we from 0 on the number line. So when we go this way, we're 13 away, and when we go this way, we're 13 away. Distances are always positive. All this negative right here means, and all this positive means, is starting at 0, what direction did we go? If we go right, then it's a positive. If we go left, then it's a negative. Okay? But the absolute value of a number, all that means is, how far am I from 0? Now, when I ask you how far something is, I'm asking you a distance. Distances are never ever in the whole history of the universe negative. You cannot go a negative 13 miles. You can only go a positive 13 miles. So when you are going from, let's say, San Francisco to Seattle, you don't say that I went 1,200 miles to Seattle, and then when you turn around and went back to San Francisco, you said I went a negative number of miles. Okay? It's always positive when you go a distance. So, the absolute value is always the distance you are from the point, and in this case, the point 0. And we write the absolute value with two vertical lines. So, if I say the absolute value is the distance from 0, is the absolute value ever a negative number? No, because you can never go a negative distance. So the absolute value of 13 is 13. That's how far I am from 0. The absolute value of negative 13 is how far am I from 0. I'm still 13. I just went in a negative direction or to the left. Okay, so the absolute value of any number is going to be a positive number. All right, and that, if you get a hold of that, then the rest of this lesson should be not too difficult. So if I ask you to graph the absolute value of x equals 4, what number can go in for x? Well, I can put a 4 in. The absolute value of 4 is 4, and the absolute value of negative 4 is also 4, because again, we're just looking at the bigness of the number. That just tells me how far I am from 0. So my answer is going to be there and there. The absolute value of x is 4. That means my number that goes inside my absolute value can either be a positive 4 or a negative 4, because they're both 4 away from 0. So the negative doesn't really have anything to do with anything except how or what direction we went from 0. We went left. The positive doesn't have anything to do with it except telling us that we went right from 0. Alright, so now let's look at the inequality part of this lesson. Alright, so example 102.1 says to graph the absolute value of x is greater than 2. Alright, so what do I know? I know that x has to be 2 or negative 2, right? It's got to be both of those, because the absolute value of x, if it's negative 2, is 2, or if it's positive 2, the answer is 2. Alright, so I know that my starting point are going to be negative 2 and 2. But it's asking me to tell you all the numbers that are further away from 0, and that's one of the things that's going to help you understand this. I'm looking for all the numbers that are further away from 0 than 2. Great numbers that are greater than 2. Okay, so what numbers are further away from 2? It can't be 2 because it doesn't give me an option to be equal to 2. So I make an open circle at 2, showing me it doesn't include. And what are the numbers that are further away from 2? They're all the numbers that go this way, right? Okay, it doesn't seem too difficult, but now I have to look at the other side. So again, I'm starting at 2, at negative 2, because that is 2 away from 0, right? And I'm looking at the numbers that are further away from 0 than 2, which means this way. All I'm looking for is the numbers that are further away from 2. So when you're doing these, you pretty much ignore the negative signs here. You're just looking for direction, this way and this way. I'm looking for numbers that are further away of 0 than 2. So even though this is negative 5, I'm not saying negative 5 is bigger than 2. I'm just saying that negative 5 is further away from 0 than 2. It takes longer to get from 0 to the negative 5 than it did to go from 0 to the negative 2. Negative 5 is further away from 0. So just ignore the negative parts here as far as making your determination, as far as which, you're not looking at which numbers are bigger, you're looking at which numbers are further away from 0. Alright, so let's look at the absolute value of x is less than or equal to 3. Alright, so the 3 tells me that I'm going to put a mark on 3 on both sides, the negative side and the positive side of the what is this called? Number line. Okay, and this equal sign means that it can include 3. Okay, so I'm going to circle a 3 here and close it in because it includes 3. Come on, close in. And here. Now what is it interested in? It's interested in all numbers that are smaller than 3, that are closer to 0 than 3. That includes all of these numbers right here, right? And you're done. So when it's asking for less than, it's asking for the numbers that are closer to 0 than this number. If this were greater than, it would be asking for all the numbers that are further away from 0 than this number. So the numbers this way and the numbers this way. Okay? So continuing on, example 102.3. Absolute value of x is less than negative 4. Alright, one of the things that you notice here is there a way for you to ever take the absolute value and get a negative number? Think about that. I said before, the absolute value of anything always tells me the distance it is from 0. Is distance ever negative? No. So this does not work, and you put an answer like that, meaning there is no answer to this. It's the empty set or the null set. Okay, so that was pretty easy. Okay, let's make a little bit of a switch here. I'm going to take that less than sign and I'm going to make it a greater than sign. Okay, so let's look again. Whenever I say I'm taking the absolute value of a number, I'm saying I want that number positive. Okay, so if I said the absolute value of x equals 4, I'm looking for the numbers that are 4 away from 0, and the answer to that would be both positive 4 and negative 4, right? Those are the two numbers that I could put in there that when I take the absolute value, I get 4. Now this here is saying what numbers can I put in here for x where the absolute value is bigger than negative 4? Well, the absolute value of every single number is positive, right? So what numbers can I put in here for x that are going to give me a value bigger than negative 4? Well, any number, right? I mean, if I put 1 in here, is 1 bigger than negative 4? Yes. What if I put negative 3 in there? Is the absolute value of negative 3 positive 3? Yes. Is that bigger than negative 4? Yes. What if I put negative 627 in there? Is the absolute value of negative 627 a positive number? Yes, and every positive number is bigger than negative 4. So the answer to this would be everything on the number line. The absolute value is going to be bigger than negative 4. Why is it going to be bigger than negative 4? Because of the negative sign. Because the absolute value of any number is positive, and any positive number is bigger than any negative number. Okay, so even though that seems kind of tricky, that's where the answer comes from. All right, let's look at example 102.5 here, and it gives me the negative absolute value of x is greater than or equal to negative 3. All right, let's look at first of all what this thing is saying. What this is saying is that the absolute value of any number is going to be positive, and then we're going to put a negative on it. And when we put a negative on it, then there are some numbers that make it bigger than negative 3 and some numbers that don't. But remember, this is a positive. This will always be a positive when you take the absolute value off. But then you have to add a negative. So for example, if I put the absolute value of negative 2 is greater than or equal to negative 3. Okay, the absolute value of negative 2 is positive 2, but I have to put that negative there. And is that greater than or equal to negative 3? Is negative 2 greater than or equal to negative 3? Yes, it's greater than negative 3. It's closer to 0 than the negative 3 is. Okay? So that's kind of the theory behind it, but let's go ahead and do it. Okay. We don't want this negative here. Okay, so if you remember what we've done in the past, if we don't want a negative in front of our x or in front of our variable, we just make it go away. But when we make it go away, we have to change the sign of this. Okay, now this is where it gets a little bit weird because of that inequality sign right there. So let's show this as negative absolute value of x is greater than or equal to negative 3. This is actually a negative 1, right? We divide by negative 1, divide by negative 1. These cancel. What did we do? We divided by negative 1, so our sign needs to switch. Negative 3 over negative 1 is positive 3. All right, so all that to say, if we have a negative in front of a variable, doesn't matter if it's an absolute or if it's just a variable, when we switch this to a positive, we can do that, and then this one over here switches to its opposite, but this has to switch too. So when you're dealing with equals, like negative x equals 3, there's nothing to switch here. So we just go x equals negative 3, right? We just take this negative off and we switch the sign of that, and that's okay. But when we're dealing with inequalities, if we have a negative here and we take it off, and we take this negative off, if we switch the signs of both sides of the inequality sign, which is fine, but if we switch the signs, we have to switch the sign. Okay, we have to change that. So this here is the same as this. Now we are going to go ahead and graph that. Alright, so the absolute value of x is less than or equal to 3. What numbers on the number line are less than or equal to 3? Well, the numbers that are equal to 3 are 3 and negative 3, right? The absolute value of negative 3 is 3, absolute value is 3 is 3. Now we're looking at the numbers that are smaller than 3. Well, all the numbers that are smaller than 3 are all the numbers closest to 0. And there would be your answer. Alright, let's look at one more in the next video and we'll be done.